This is a light-up PCB pin I made for Halloween this year. I've used 1206 and 0805 surface mount components and hand soldered them onto the board. You can see on this board without the components how the core layer is exposed underneath the LEDs, which helps to diffuse the light. The LEDs are soldered upside down, which makes them a bit trickier to solder, but when done properly, the semi-transparent PCB core diffuses the light and creates this soft glow. In this video, I will walk you through my design process, including how I made the board in KiCad and how you can build one yourself. All the files for the project, along with an interactive guide for soldering, are available on my website, which is linked in the description. Light-up PCB pins have been around for a while now. You can find them on stores like Tindy. Most of them use standard surface mount LEDs on the top layer of the PCB, as you can see on this owl. There are also designs that diffuse the light through the PCB's core substrate. These typically require stacking multiple PCB layers or bending through-hole LEDs to shine light into the core, as seen on this cat and ghost. Another approach that some makers have used is soldering SMD LEDs upside down, as seen on this Marks and Angles pin by Gizmolab. The light shines into the PCB core directly, which creates a diffused glow. To accomplish this, both the upper and lower solder mask layers are removed, allowing light to pass through the exposed fiberglass core, which naturally diffuses the light. I wanted to explore this technique as well, to experiment with light diffusion using only the PCB core. My initial idea was to create a simple jack-o'-lantern pin, but the battery was taking too much space, so I had to adjust the design to make room for the battery. That's how I ended up with this final drawing, a ghost wearing a pumpkin on its head. Procreate doesn't export vector files directly, but you can easily convert your artwork layer by layer by importing it into Figma and exporting the layer as SVG files. It might be a better idea to use a vector-based software like Inkscape for this kind of work. I'm using Procreate mainly because I'm familiar with it. Once that was done, the design was ready to be brought into KiCad. The first step was creating the schematic for the LEDs. For this project, I used 5 LEDs in parallel, each paired with its own resistor, powered by a CR2032 coin cell battery. For the PCB layout, I imported my artwork layer by layer. The key detail here is that the part where you want the light to shine through must be imported as F-mask, which is used to create custom solder mask openings. For the backside, where the LEDs are mounted, I used KiCad's rectangle tool to manually draw the cutouts with B-mask and fill them in. After finalizing the layout, I sent the board for manufacturing. For the PCB, I chose a black solder mask with a gold enig finish as the solder paste to achieve the pumpkin look. As for the components, I've ordered 1206 orange color LEDs, along with 0805 200 ohm resistors to achieve 6 to 8 hours battery life. Soldering the components was a bit challenging, because the LEDs had to be mounted upside down. The method that worked best for me was to first place a small blob of solder on the tip of the soldering iron and use it to attach one side of the LED. After that, I soldered the other side by carefully applying solder from both the top and the bottom to ensure proper electrical contact. After the LEDs were in place, soldering the remaining components was relatively straightforward. For the battery holder, I got these coin cell battery clips, which have the perfect size for this project, and can be easily hand soldered to the board. As for the pins, I found these cheap craft pins on Amazon that can be soldered onto the board and are surprisingly sturdy. With that, the soldering is complete. I made these pins as Halloween gifts for my friends, so I thought it would be fun to attach them to custom Halloween cards. I designed the cards in Figma and left a small space under the text to write each friend's name. I also drew guidelines to make cuts to attach the pins. With that, the Halloween pins were complete,